Alright, so this is the second period video where we'll do the odds of the review. So first go is to plug in 5, but my guess is, well, I shouldn't say my guess is it won't work because it's the first one, so maybe they sneak one in that works. 25 minus 15 minus 10. Uh-oh, that's 0. 25 minus 25 is 0. So yeah, right away they're making us do some work here. That looks like a factor and cancel problem. Minus 5x plus 2. X minus 5x plus 5. The 5 is the problem. So I sort of knew already that I was hoping x minus 5 would show up and cancel. That way x equals 5 isn't the problem anymore. So, I mean, hopefully factoring is not a struggle for you. But if it is, you can sort of guess what one of the factors is going to be from the beginning. All right, now substitute 5 in again. 7 over 10. 20 is kind of the same thing. What do you think? We're not going to do 20. What do you think one of the factors is going to be, even before we even look at the problem? Probably x plus 1, because we'll need x plus 1 to cancel, so the negative 1 will work. So you kind of get the hang of these, and you get a little hint on factoring. 21. If I plug in 0, I'm definitely getting 0 over 0. So let's take out a 2x. That leaves x squared plus 1. And then a 3x. That leaves 1 minus 4x. So the x's will go away. And then which is good because 0 is the problem. So let's plug in 0 and we get 2 times 1 over 3 times 1. And being pressed for space, we can box that up as our answer. Right? We can safe stop that. Multiple choice would simplify, but you can do that. 22 is factoring a cubic, but you can remember how to do that. 23, that does not look like a 0 over 0 about to happen, because cosine of x plus 4, I don't think that's going to be 0. So this is more of a unit circle problem than anything. Okay, this might be the greatest day in some of your math life, because what I've written is calculator ready. It does not include any calculus, and so that is a safe stop. You're like, well, why didn't they let us safe stop that in pre-cal? Like, well, that was the whole point of pre-cal, was knowing that. So that's why you're not allowed to safe stop that in pre-cal. Oh, this thing likes to freeze my face down here. Try that again. But in calculus, it is a safe stop. I guess the bad news is going to be that that's probably a multiple choice question, and that's not going to be one of your answer choices. They're going to simplify it. So as a free response, you absolutely can leave trig stuff like that, but usually it's a multiple choice question, and so you've got to do some work. So let's see, that's root 3 over cosine of pi over 3 is 1/2. Yeah. That's another safe stop. And it's like, well, how far do we need to go here? That's a safe stop. If I keep it, change it, flip it, I get 2 root 3 over 9. That's probably the multiple choice answer. So, yeah, get excited about leaving the trig stuff, but multiple choice is going to force you to know your trig. Oh, I just realized this. This is why it looks like this worksheet has so many problems. Is because we went from 23 to 34. 35. Oh, this is still in our algebra bag of tricks here. If I plug in 3, 1/3 minus 1/3 is 0. 3 minus 3 is 0. So that looks like 0 over 0. That can't be our answer. So So let's multiply by 3 and x. So the first term becomes x, the second term becomes minus 3, and then in the bottom, 3x times x minus 3. Hey, what do you know? The x minus 3 is canceled. Again, maybe we should have known that from the beginning. If 3 is messing things up, then it's likely that x minus 3 will cancel. So we plug in 3 again, and we get 1/9.
I just want to do our answers like this on the response. We need to put the limits. We need to put the limit.
Yes, officially, if you're writing the formal answer, then I would want to see limit there. If it's a multiple choice question and you're just kind of shortcutting things, well, that's okay. I will say that I do give partial credit on multiple choice questions in here. So do show something, right? Don't just circle 1/9 as a guess. Like, show me that you tried to get there, and if I can tell that you were kind of on the right track, we do give some partial credit for multiple choice. Like, when possible. Like, sometimes it's not possible, but we look for it. We try. 36, another fraction problem that I'm guessing x minus 1 is going to cancel somewhere so that 1 will work. 37, if I plug in 3, I get 3 minus 3, 3 minus 3, so this is good. This is the third algebra trick. Oops, x plus square root 6 plus 6, x plus square root 6 plus x. So multiplying by the conjugate. And remember, we really only multiply the conjugate side of the fraction. We leave the other side alone and hope that something cancels out. Multiplying by conjugates is nice because x times x is x squared. The middle terms would be a mess, but they'd be a mess that cancels. Right? That's the whole point of conjugates, is the O and the ifoil cancel each other out. So minus, let's be careful here, it's minus 6 plus x, minus all of that. So that negative will need to distribute. And then in the bottom, x minus 3, and is this problem messed up? What did I mess up here? Oh, that's x squared. Yes. Oh, so now the top will factor x squared minus x minus 6. There's my x minus 3 that I was looking for. So I factor the top. That gets me the x minus 3 that I was expecting because I want it to cancel. Now we try again with the substitution. Again, if you're just quickly working through a test, you're probably, and even I didn't write it every time like I guess I should. But officially, I'm still doing the limit as x approaches 3. So 3 plus 2 is 5. And then in the bottom, I've got 3 plus square root of 6 plus 3. That's a safe stop. So if it's free response, leave it. If it's multiple choice, a little bit more work to be done. 3 plus 3 is 6. Okay, so that we saw all three algebra tricks like right there in a row. The factor and cancel, the fraction and cancel, and then the conjugate and cancel. They all sort of have the same last couple steps. Cancel the factor that's a problem, and then resubstitute in and hopefully get an answer, a nice answer. All right, 39, we get to some one-sided limits. So if I plug in, all right, first go is just plug in 2, see what happens. 2 minus 5 is negative 3. Negative 3 over 0. Uh-oh. That doesn't work. Although, if I'm dividing by a really small number, like I know it's going to be positive or negative infinity. And now I just need to be careful about which one it is. Let's see, 2 minus 5 That's negative 3. It's the 0 I'm worried about. 2 minus something less than 2. Again, how much work you show, up to you. Something less than 2. 2 from the left would be like 1.99. So it's negative 3 divided by a positive number. That's what we're going for here. So this is going to end up being negative infinity. So if you get 0 on the bottom, you're headed toward infinity, but then you got to really slow it down and be careful about which infinity you're headed toward. While we're here, 38. 38 is like the flip of the reciprocal of 39. If you plug in 2, you get 0 over negative 3. And 0 divided by negative 3 is 0. So I didn't have to worry about the plus or minus on that one because I got a decent answer. It's when you get weird answers that you better slow down and be careful. All right, 41. X goes to infinity. So when x goes to infinity, the only terms that matter are the big terms. So 3x to the 5th over negative 12x cubed. That would be x squared over negative 4. So as x gets really, really big, x squared gets really, really big. But divided by negative 4 would make it negative infinity. So again, as x gets really big, the only terms that matter are the big ones, and then go from there. 43, plugging in negative infinity, so extra careful. Same process though. Biggest term in the top, biggest term in the bottom. 3x to the 6th over negative 12x cubed. So that would be x cubed over negative 4. Oh, I got lots of negatives. So if I plug in negative infinity and I cube it, the top becomes negative infinity and the bottom is negative 4. So what's my answer here? Positive infinity. That was a weird one. All the negatives. Yeah, I guess not weird from a calculus point of view, just tricky from an algebra point of view with all the negatives. 45. Surely that's just a plug in and see what happens. Hopefully there's not a conjugate thing going on here. 2 tangent pi minus 4 sine of pi over 3 cosine of pi. Well, you'll pardon me while I draw the angle pi so that I can answer these questions a little easier. There's pi. So sine is 0, tangent is 0. And cosine is negative 1, which is good because 0 divided by negative 3 is just 0. That wasn't really a calculus or a limit question. That was just more of a pre-calc question. 47. Discontinuity. Okay, anything in the bottom, anything that makes the bottom 0 is going to be a problem. So some of you would just look at that and tell me the answers. Others would factor it first and tell me the answers. X plus 3, x minus 3. So it's discontinuous at x equals plus or minus 3. And I can answer that particular question without factoring the top. What would the question be for me to have to factor the top and examine further what's going on? What type of discontinuities? Because if they cancel, it'd be a whole. If it doesn't cancel, it's an asymptote. And it looks like there's one of each, but that doesn't matter because it just said discontinuity. So, I mean, yeah, you could keep going and answer, give it more detail. So there's a hole at -3 and a vertical asymptote at x equals 3, but that's more than the question called for. Which of the following is continuous at x equals 1? This first one potentially has a hole. X minus 2, x minus 1 over x minus 1. So I can cancel the x minus 1s. Means there's a hole there. I plug in 1. 1 minus 2 is -1. So that top graph has a hole at -1. The bottom part does not fill the hole in, so this thing is not continuous. If we tried to graph it, there'd be a hole there at -1, but the dot is at a +1, so yeah, that doesn't work. They didn't fill that in right. Roman numeral 2 is a left-right issue. So does the limit from the left equal the limit from the right? So we plug 1 into both pieces and see what happens. Half of 2 plus 4 plus 1. Let's see, half of 6 is 3, plus 1 is 4. And they give us a break on the bottom one. If I plug in 1 there, 5 minus 1 is 4. So we're good there. Like the left limit equals the right limit, so 2 is good. So 1 is out, 2 is good, 1 is out, 2 is good. So I need to check on 3. That looks like another. If it's just about continuity, I don't even have to factor the top. Right? This thing is not continuous at x equals 1. And kind of like that last problem, I don't know what's happening at 1 until I factor the top and see if it cancels or not, but it doesn't matter for this question. It's not continuous at 1. So 2 only was the only continuous one. We're skipping over the K problem in this video, but you remember how to do that one? Set them equal to each other at 1/4. So that'd be kind of a pain with the fractions, but the from the left equals from the right and solve for K. 51. Let's see. I've talked enough. Let's pick on some people here. So let's just get a true-false on each of these 3 statements. James, Autumn, Austin. So James, I got to move him out of the way so I can see the picture here. James, G has an infinite discontinuity at x equals -7. True or false? True. I agree. Autumn, G has a non-removable discontinuity at x equals -1. That is false. You're right. Because that is a removable discontinuity, because all you'd have to do is fill the hole and you'd be good. So false. And then Austin's statement number 3, G has a removable discontinuity at x equals -6.
False.
That is false. Like, that's not fixable. That's a jump. You can't fix that. Mm-hmm.
Mr. Conley said the second one was true.
Second one is true. Okay. I don't want to doubt Mr. Conley.
It was true.
Has a non-removable discontinuity at x equals -1. At x equals -1, there's a hole there, and I can fix it so it's removable. So I'm going to say that statement's false.
You told me it was true. I don't know what you said was true.
I'm going to argue with the great Mr. Conley on that one. I know, I'm going to say it's A. Tell Mr. Conley I'll meet him out back after school and then we'll fight it out. '53. Prove. Oh, no. Prove. Your least favorite word in all of math. maybe let's change that though. Least favorite word in all of geometry, right? It's okay in here because did you? I think that puts you in a minority. It's okay, and I'm glad you did. But just judging by the facial reactions to your comment, I don't think you're in the majority on that one. Okay, 3-step proof for continuity is left limit equals right limit equals function value. I should probably make you say that with me and do the hand motions. Left limit equals right limit equals function value. Sometimes I write that out. Other times I jump straight to like the formal limit from the left equals limit from the right. Whoops, I did that out of order. Guess it wouldn't matter because either way is fine. Left limit equals right limit equals function value. That's our continuity proof. Now I need to show more than that, but that's how we get started. So from the left, I'm less than 0. I'm over here. They're going to make me do work on this, because if I plug in 0, I get 0 over 0. So let's see. If I factor out an x, I get x plus 4. If I factor out a 2x, I get 2x plus 1. Now I can cancel the 0, or cancel the x's, which would cancel the zeros. And if I plug in 0, I get 4 over 2 times 1 is 2, so I get 2. Okay, so the limit from the left is 2. That one took a little work. The limit from the right, that'll be a little easier, because it's just a polynomial. 0 plus 0 plus 2 is 2. And the function value, so that means the equal sign, like at 0, the equal sign, is still this same equation, 0 plus 0 plus 2 is 2. Therefore, f of x is continuous at x equals 0. Left limit equals right limit equals function value for a proof. And for a determine, it kind of works the same way. You're going to set it up the same way and then see if it breaks down somewhere. And I think it will. Yeah. Yeah, it will. 55. What is the limit as x approaches 2? Okay. Maybe a trick question. Which, if x is approaching 2, which branch should I plug it in? The top one or the bottom one? If we're thinking about limits. So that's a bit of a trick question. Both. Because you've got to check the left and the right. If it was just f of 2, then we would only plug it in the top. We wouldn't care about the other one. But limit means I got to think about coming from both sides. So I really do need to plug it into both pieces and hope that they, well, if they don't give me the same thing, then it does not exist. If they do give me the same thing, well, it better be one of those answers. So natural log of 16 divided by 2. And then on the other side, I get 2 natural log of 2. Are those the same thing? They don't look like it right now. Properties of natural logs. Let's do the one without the fraction first. What can I do with that 2? Yeah, it can be that exponent. So that side could be natural log of 4, which maybe is our answer. On the left side, if I rewrote this as 1/2 natural log of 16, now the 1/2 can go up there. I square root the 16, and I get natural log of 4. You can boo that question if you like, because that's not testing your calculus knowledge. That's testing your properties of logs knowledge. $57. Uh-oh, we're almost out of time. I'm not close to the end, although we did a bunch of IVT already. So, you tell me. I guess I can record those later and post them separately. I'll do that. I'll record the rest of the odds later and label it and post it and all that stuff. You guys don't have the test till Thursday, so you can't see me before lunch on Thursday. But you got a couple days anyway to figure things out, watch videos. Come see me if you need me. Yeah.